grade 10 to 12 and GCE. We also offer IGCSE, Cambridge and A-level. The courses that we have or subjects available are mathematics, physics, biology, chemistry and additional mathematics, otherwise known as ATMA. So in this video, we are going to focus mainly on questions coming from ammonia. So to say, we are going to answer questions from ammonia. Okay, so this is the first question that we are going to answer. So this question came in 2016. It came in 2016, that is GCE. Okay, as you can see the question, this was question 12. Now let us go through the question. So the question reads, or the first part of the question reads, when the mixture of ammonia sulfate and sodium hydroxide is heated, the reaction is represented by the word equation below. So this is the word equation that you are able to see. Ammonium sulfate plus sodium hydroxide producing sodium sulfate plus water plus ammonia. The first question here is write the balanced chemical equation for the reaction above. So now we have the word equation and now we are asked to write the balanced chemical equation. Now remember from the basics, writing the balanced chemical equation, you need the symbols or the chemical formulae for the compounds that are reacting in this case. So now what is reacting here is ammonium sulfate. How do you write ammonium sulfate? Ammonium sulfate is written like this. Ammonium sulfate is written like this. If you can't remember, or I don't know, you're wondering why it is written like this, I bet you need to go back to the basics on how to write the chemical formulae, or you might need that information. So this is ammonium sulfate, and of course we have also sodium hydroxide. Now how is it sodium hydroxide written? Sodium hydroxide is presented as this. So sodium hydroxide, like this. So this is sodium hydroxide. And of course what is produced here is very important also to know the symbol for, the chemical formula for sodium sulfate. So sodium sulfate is written as this. And now we have water, which is the simplest one, H2O. We have ammonia, which is NH3. So these are the ones that you need for you to write the equation. So now, since we are saying ammonium sulfate react with the sodium hydroxide, so we are going to start writing now. So let me just put it here under the question. So ammonium, I'll write it like this. I hope it will fit in this space, or maybe I can just use this space here. So this is A. We can say ammonium sulfate, which is a salt. So this process, please, let me just emphasize also that this is how you prepare ammonia at laboratory level, where you react ammonium salt with a base. And in this case, the base is sodium hydroxide and ammonium salt is ammonium sulfate. But in other cases, you're going to find a different one, as we are going to see as we go on. So this is ammonium sulfate, and of course, we can put it is in aqueous state, okay, which is in aqueous state, and now it is reacting with sodium hydroxide, which is also in aqueous state. And of course, in this case, what is formed is sodium hydroxide, this one. Sodium sulfate plus H2O plus ammonia. Now remember the question is write the balanced chemical equation. So in order to balance the equation, I'm sure you have the knowledge about balancing the equation. You just need to balance the atoms that are involved on the reactant side and of course on the product side. They should be equal. So in this case, the atoms that are involved here is the nitrogen, hydrogen, oxygen, sulfur and sodium. So these are these that are this side. So here is nitrogen, please. Here is hydrogen. Here is our sulfur. Here is oxygen. There's also oxygen. So oxygen, just write it once. Then there's sodium here. And of course, yeah, that is what you have. So what you have on the reactant should be what you have also on the product side. So this to say you have nitrogen, hydrogen, oxygen, sulfur, sodium. So now the number of nitrogen this side should balance with the number of nitrogen the other side. That is the basics about balancing the equation. So I'm just going to go through and of course put numbers that balances the equation. since you know where we are coming from. If you have a problem on balancing the equations, okay, you can just give me, you can comment so that maybe I can prepare that part. So this is a 2. We are going to put a 2 here in front, and of course in front of water, we're also going to put a 2. Then in front of ammonia, we're also going to put a 2. Okay, so this balances the equation. And by the way, this is in aqueous state, this is a liquid, and this is a gas. So we've written the balance equation. So that is how you basically write it. Remember what I said, if you have challenges here, please, you can request for that part so that I can, or we can arrange. So this is the first question. That is 2 marks. Describe the chemical test that you carry out to show that ammonia is formed. So what is a chemical test? So the test for ammonia, you know that the presence of ammonia, it turns red litmus paper blue. So how do you carry out the experiment? So we're going to say place the what? Red litmus, that is what you're going to use, red litmus paper, to the vapor containing or suspected to contain ammonia. Okay, suspected to contain ammonia. If it turns blue, meaning what? Meaning ammonia, or the gas is ammonia. Ammonia is produced. Okay, so place the red litmus paper to the vapor, and if it turns, let me just say to the vapor, and if it turns blue, meaning ammonia is produced or ammonia is present. So that is the reaction. I mean, that is the test that you carry out. Okay, so which question are we answering? This time around we are answering question C. So I can, okay, I guess the space will be enough. So on a large scale, ammonia is produced by the process, or by the Haber process. So Haber process is the process by which ammonia is produced at industrial level. What are the reactants in the Haber process? So the reactant in the Haber process is hydrogen, and nitrogen. Now it's very important also to know the origin of this. So hydrogen is coming from steam deforming or cracking. Then nitrogen is coming from fractional distillation of liquid air. So it's very important to know where these are coming from. Okay? Then write the balance equation for the Haber process. So in this case, hydrogen and nitrogen are reacting, and this reaction occurs in the conveyor chamber. If you look at the Haber process. So in terms of reaction, we can say, we're writing it here. So hydrogen react with nitrogen. What is formed is the ammonia, like this. So what is remaining is to balance the what? The equation. So how do you balance the equation? So in balancing the equation, we're going to put a 2 here in front of nitrogen, and of course a 3 here in front of hydrogen. So this balances the what? The equation. You can write the state symbols. This is a gas, and also this is a gas, and also this is what? The gas. Now there are conditions that are involved. I'm sure the other question that will be asked is writing the conditions. Okay, so this is the balance equation. Let me just clean up this part for the solution for question 3 for C. So now let me just rub these state symbols and of course expose the question. So the question reads: state the essential conditions. State the essential conditions used in order to obtain an economical yield of ammonia. So in short, what are the conditions necessary for industrial preparation of ammonia? So one of the conditions is a catalyst. A catalyst. Now a catalyst that is used in this case is iron. Okay, iron written as the Fe. Okay, iron written as Fe, that is the catalyst, or iron pellet, which is the same. Then temperature is one of the conditions. So there's high temperature there. So temperature of around in the Haber process, the temperature of around 450 to 500 degrees Celsius. And of course we have also the pressure. So pressure of around 250 atm. Okay, so these are the conditions necessary. So we fully answered this question, and this gives us a 10 marks. Let us look at the second question. The diagram below illustrates the laboratory preparation of ammonia. So we're still on ammonia. Like I said, in this one we'll focus on ammonia. So this is the laboratory preparation of ammonia, just like the first one. This first part is also how you prepare ammonia at laboratory level. I said you react with a salt and a base. But a base, any ammonium salt is short. And of course any base. In this case, the base that is here, it is different from the first one. This time around you have ammonium chloride as a base. No, as a salt. Then you have a base which is calcium hydroxide. Now it's very important here to know that ammonium chloride, this one, is written as NH4Cl, and calcium hydroxide is written as CaOH2. It's going to make our work easier as we start looking at the equation. So the first one, as usual, construct the balanced chemical equation for a reaction being illustrated in the diagram above. So let us construct the equation. So we're going to use this. So ammonium chloride is reacting with calcium. Oh, we are writing the chemical equation. So it's reacting with calcium hydroxide. What is formed here? What is going to form is calcium chloride plus water. I'll just write the balanced one, and plus 2 ammonia. Okay, 2 ammonia. So this is the gas, this is the liquid, this is aqueous, this is aqueous, this is aqueous, this is what? This is as well aqueous. So this is the balanced equation. Of course, in front of ammonium chloride there is a 2. Okay, so this is the balanced chemical equation we can talk of. Then now, what is the other question? So please counter check the equation. The other question is this one. State the common name of a substance X. So the substance X that you are seeing here is pointing inside here, and of course the whole of this is called calcium hydroxide tau. Calcium oxide tau. So substance X is calcium oxide. So substance X is what? Calcium oxide. And now, what is the purpose of calcium oxide? So when ammonia is produced here, it all moves up to down here. You remember, or you know that water is part of the products here. So ammonia that escape here might contain some moisture. So when it reaches here, it is dried by calcium hydroxide. So therefore we say to dry ammonia. So that is the purpose of the calcium hydroxide or calcium oxide. Why is ammonia corrected by the method shown above? Why is it corrected by the method shown above? So why is it corrected by method shown above and not water? So because ammonia is soluble in what? In water, and less dense than air. That is the reason why it is corrected by this method. It's soluble in water, so it cannot be collected using downward displacement of water, because it's soluble in water, and of course it's less dense than air, therefore it can be corrected by this method. Okay, so the other question here is describe the chemical test for ammonia. So that is question D. Describe the chemical test for ammonia. How do you test for ammonia? So for ammonia, the way you test for ammonia is that you put the damp red litmus paper into the vessel containing ammonia, or that you suspect to contain ammonia, and of course it turns the damp litmus paper red. So it turns damp litmus, damp red litmus paper, red. Damp red litmus paper blue, please, blue. So it turns damp litmus paper, red litmus paper blue. Then state 2 uses of ammonia. What are the uses of ammonia? So it is used in making of what? Used in making of fertilizer. So you've heard of ammonium fertilizer. So it is used in making of fertilizer. Please take note of this. I guess the point is clear, or you are able to get it. Okay, so used to make or manufacture of fertilizer. So used to make fertilizer. Let me put used in manufacturing of fertilizer. Okay, used in manufacture of fertilizer. It is used in making nitric acid, please. So take note of that. Used in making nitric acid. Let's answer now this question. So nitrogen is used in manufacture of ammonia as shown in the diagram below. As you can see the diagram. Name the process shown above. Name the process shown above. So this process that you are seeing above is called Haber process, because it's a process at which ammonia is made at industrial level. Okay, so where nitrogen and of course the other reactant that you are going to name here is reacted. So it's called Haber process. State the substance represented by letter X. So substance represented by letter X, nitrogen react with hydrogen. So this is the hydrogen, okay, to form ammonia. Write the conditions represented by Y and of course Z. So Y, please, must have been Y degrees Celsius. So the condition represented by Y is equals to what? The temperature. Okay, temperature. And of course the temperature of about 450 to 500 degrees Celsius. Then of course Z, as you can see, ATM. So Z, ATM is pressure. So this is pressure. Pressure of around 250 atm. Okay, 250 atm. So that is the 250 atm. That is the pressure. Okay, so the two conditions are one, the temperature here, temperature, and of course of that number, amount, and here we have what? Pressure. So these are the conditions. But of course there's also a catalyst. Catalyst that is used here. I'm sure we're going to find the question as we go on. Then of course D, name the catalyst used. So the catalyst used in this case is what? Ion. Remember where we're coming from. We had looked at that already. So ion. Okay. Then now write the many ore from which the catalyst named in D1 is extracted. So the question is, from which ore is iron extracted? That is the question. So iron, it happens that is extracted from hematite. Okay, so hematite, otherwise as the iron oxide. Iron oxide. It's a principal ore for iron extraction, hematite. Construct the balanced chemical equation for the reaction shown in the diagram. Include state symbols. So this reaction that you are seeing above, which means hydrogen is going to react with what? With nitrogen. And of course we had written this equation at some point. Okay, so is hydrogen plus nitrogen. What is produced is the ammonia. To write it balanced chemical equation, we're simply going to add a 2 here and of course a 3 here. This is a gas, this is a gas, and of course this is a gas. So we had written the balanced equation. State one use of ammonia. So we had looked at the uses of ammonia already. So used in what? Making of fertilizer, fertilizer. Also used in making what? Making of nitric acid. Also used in making or used in refrigerating. Okay. So basically, this is how we answer the question. Okay, this is where it ends. So please, if you found this video helpful, make sure if you're watching me from Facebook, like my page. If you're watching me from YouTube, kindly like, subscribe to my YouTube channel, and don't forget to invite your friends, turn on the notification bell. Whenever I post the new materials, you'll be notified. So this is a revision program, and of course it's going to help you even as you prepare for exams. We are yet to cover more parts on non-metals. We are yet to look at oxygen. We are yet to look at, let me just show you the questions that we are yet to revise. So we are yet to revise the questions such as this one, yet to revise this question, yet to answer this question, yet to answer this question, 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 and of course up to we are done with all the questions under non-metals. So I'll be releasing the questions per part. So we are starting with the first one for ammonia. So please see you in the next one.